Hello again, math students. Today we are going to still be working with scientific notation, but instead of taking numbers that are in scientific notation and changing them into standard form, so reading numbers in scientific notation, now we're going to be taking numbers and putting them into scientific notation. We're going to be writing scientific notation. Today is, again, very much about the size of the factor, the number that's before the times 10 to whatever power. So we have to be able to move our decimal so that we've got one number in front of the decimal that's not a zero. And then we'll have to count how many places we moved, and that'll help us to determine what our exponent should be on the 10. So in this example, if I have a number that's greater than or equal to 10, so I'm starting with 8,600, I want to first of all realize that it's a big number, which means I'm going to get a positive exponent. So you can already see what this answer is, but my decimal started right here. And to get it into the right place, to get one number in front of the decimal that's not a zero, I had to move 3 places. 1, 2, 3. Now it's right here between the 8 and the 6. So that's where my 8.6 comes from. That's my factor. Now we've got our x for the multiply. Yuck, but I can't control that. And then the 3 tells me how many places I moved my decimal. When I look at a small number, so a number that's less than 1, that's when we're going to have a negative exponent. Now, it does say a number between 0 and 1. I'm not going to worry too much about negative numbers right now. So we're talking about a decimal all the way up to almost to 1. Those would be the small numbers that we're talking about. So if I start with 0.0024, again, getting the decimal into the right place, getting the factor figured out, that's the important part. I need my decimal to be right here. So it's a 2.4. I can't move it over one place and say I've got 0.024. Nope, that won't work. I can't even start right here and say I've got 0.24. That's not okay. I can't have a 0 in front of the decimal. I have to have one number that's not a 0, so 2. So I had to move 3 places. Both of these problems, I moved 3 places. However, because it's a small number, I need a negative exponent. That's what tells me that it's a small number. Again, I mentioned in the last lesson, I don't want you to have to memorize moving left or right. I want you to be thinking, if it's a small number, I get a negative exponent. If it's a big number, I get a positive exponent. So we've got this. Google purchased YouTube for we've been talking in class a little bit about reading this, right? So with 6 zeros, that's a million, but this is more than that. This is $1,650,000,000. I want to write this in scientific notation. I need my decimal to go into the right place, which would be right there. Okay, not because there's a comma there, but because I've got one number that's non-zero, then one number in front of the decimal. So when I write this, I'm going to get 1.65. Here's the nice thing about scientific notation. I don't need to write all those zeros now, because now they're after my decimal. And this is going to be times 10 to, and then that's where we figure out how many places we moved, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 places. There's my exponent. Okay, 1.65 times 10 to the 9th. Again, it's a big number, really big number. Sorry for the bell. Really big number, so that means it's going to be a positive exponent. But my factor is the right size. It's now more than 1, less than 10. This fact kind of makes my brain hurt a little bit. In 2004, an Indonesian earthquake slowed the rotation of the Earth. It made the length of our day, it's a fraction of a second. It's very, very small. But there was an earthquake that was significant enough to change the rotation of the Earth. So we lost a fraction of a second per day. Really small number. I should be thinking negative exponent immediately. And I need to figure out where my decimal goes so that I can get the right factor. So I need one number in front of the decimal that's not a 0. That means it's going to go right here. So it'll be 2.68 times 10. We know it's going to be a negative exponent. You can put the negative right away. Now I just have to count how many places I have to move over. 1, 2, 3, 4, 5, 6 places. So it's a negative 6 for my exponent. For 1, 2, and 3, this is changing from scientific notation into standard form. We've already practiced this, right? So in number 1, be careful because there's really a decimal right here. So it's really 7.0 if you wanted to. I am moving my decimal 7 places, and it's a positive, which means it's going to get bigger. So I would have my 7, and then I'd move over 7 places, which means really just add 7 zeros in this case, since there weren't any other numbers. 1, 2, 3, 4, 5, 6, 7. And then again, with big numbers, we like to put in some commas to make it easier to read. For number 2, negative exponent is going to be a small number. So I'm going to move 4 places. Some people don't like to do the little swoopy things with zeros. You can, or you don't have to. It's going to take me 1 place just to get in front of the 2. And then I still have 3 more places to move. So when I do this, I don't even bother drawing that little swoopy thing in. Usually I would start with my decimal and say 1, 2, 3 zeros. And then I needed 1 place to get in front of the 2. Now, just looking at that, that's my 4 places that I moved. And then I put my 7 there. If you want to do this, 1, 2, 3, 4. I know I'm writing right over the problem number, but that'd be my 0.00027. 1.66 times 10 to the 9th means I'm moving 9 places. It's a positive exponent, which means it's going to be a big number. So I'll move to the right. And I usually just write down my actual number right there. And again, if you want to do like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then fill in with zeros, you can. Personally, I usually don't do that. I would say it's going to take me 2 places to get to the end of the 6, and then I still have 7 more, which would be the 7 zeros that I just added. Then you can put in your comments if you'd like. That was review. Now this is what we're doing today. I want to change these numbers into scientific notation. I want to write them in scientific notation. 4 and 5 are similar on purpose. In number 4, I need to move my decimal so that it goes here. I want it to be 5 or 5.0. Honestly, in scientific notation, a lot of times I do write my 5.0, but if you just wrote 5, it'd be okay. Sorry again. Now, I just have to count how many places I moved. It's a big number. It's going to be a positive exponent. 1, 2, 3, 4 places. In number 5, I've got a small number. It'll be a negative exponent. But again, my decimal has to go right here. It can be a 5.0 again, or I could just have a 0 right there so you can see it. 5.0 times 10 to the 1, 2, 3 places, but it was small, so negative. 683, realistically, not a number that you would normally write into scientific notation. It's not that big. Usually scientific notation is for really big or really small numbers. This one isn't all that big, but I can still write it in scientific notation. I need my decimal to go here. So it'll be 6.83 times 10 to the second. In number 7, I want my decimal to go here. So it's 3.6 times 10 to the 1, 2, 3, 4, 5, 6. And again, a lot of people count and they just write the 6 and then they forget about it. This was a small number. It's a negative. In number 8, my decimal has to go right here. So I need the 2.05. After the 5, I've got zeros. I don't need to write those down. Times 10 to the 1, 2, 3, 4. Number 9, I'm going to get 5.06. Didn't bother drawing my arrow that time. I hope that you're okay with that. It's going to be a small number, which negative. 1, 2, 3, 4. So -4 on that one. These are problems that both have a mistake. In number 10, I want to figure out what the problem is. I had 0.000036, and I'm going to move my decimal 5 places. I agree. The factor's the right size. The issue is that this was a small number. This should be a negative exponent. Okay, and I've been saying through all of these, that's the really common mistake. Forget the negative. In number 11, it's a big number, it's a positive exponent, we're fine there. But the problem is with the factor. This number does not work for scientific notation. The decimal is not in the right place. We need to actually move this one more place to put it right there. So it'd be 7.25. And then instead of only moving 6 places, I would really be moving 7. For these last couple of problems, putting these numbers in order from least to greatest, it's going to start with the exponent on the 10. The bigger the exponent on the 10, the bigger the number is. If the exponents match, then we have to look at the factors. But when we're looking at just size in general of these numbers, I worry much more about the exponents. So in number 7, I have 2 problems, or 2 numbers here, that both have an 8 for an exponent, 10 to the 8th. 10 to the 8th is smaller than 10 to the 9th. So I know that that middle number, that 5.3 times 10 to the 9th, that's my biggest number. Now that I know that the first and the third one have the same power, now I look at the decimals, the factors. 2.3 is smaller than 6.4. If you want to write these out as regular numbers to compare them, go ahead, but you really don't need to. So I would have 2.3 times 10 to the 8th, that's the first one. 6.4 times 10 to the 8th, and then 5.3 times 10 to the 9th. In number 8, I have all of them with the same exponent, which makes it more difficult. And sometimes this might be a little confusing. If you want to write these as regular numbers, you can. Negative exponents mean small numbers, so each of these is going to move my decimal 3 places, but it's got to be a small number. So this is really 0.0091. This is 0.0096. This is 0.00902. Now, for some people, that really helps. For other people, they might be like, why is Mrs. Kimby bothering with this? We can tell how big they are, right? All of these start with 0.009. 0.009, 0.009. Then the next, or the smallest number as my next digit, a 1, a 6, or a 0, the 0 is the smallest one. So 9.02 times 10 to the negative third. That's my first one. Then if I'm looking at the 1 versus the 6, the 1 is smaller. So 9.1 times 10 to the negative third. And then the last one is going to be 9.6 times 10 to the negative third. And if you look at the original problems, you could have just compared the decimals the way that they were written. 9.1, 9.6, 9.0. You should be able to know that the 9.0, 9.02, sure, but 9.0 is the smallest one out of those. Here, we have all different exponents, which makes it, I think, easier. This is going to be, as the smallest exponent, 7.3 times 10 to the 7th. Now, it is the biggest factor, which is what they're trying to trick you with, but it's got the smallest exponent. Then 3.7 times 10 to the 9th. And then finally 5.6 times 10 to the 10th. And for the last problem, different exponents again. The smaller the exponent, the smaller the number. So clearly, this one with a negative 15 for an exponent, that is way small. So 2.01 times 10 to the negative 15th would be first. And then negative 5 is smaller than negative 2. So I would have 1.4 times 10 to the negative 5th. And the last one is going to be 6.3 times 10 to the negative 2. Today's homework, the practice problems are from your book again. There's going to be a Schoology PDF in Schoology for you. And in fact, I think this is all on page 446. I think I should have taken off the 447. The answer key is in Schoology for you, so you can check those, and then make sure that you take the learning check when you're all done. If you have any questions, let me know.